Today, Brian's going to be going over something really interesting where he's going to show us how to manage motion in Inventor assemblies. And the reason we came up with this is we initially thought of doing something along the lines of like just going over constraints and joints, but we wanted to go a little further than that, right? Everyone uses constraints.
Yeah.
Some people use joints in your assembly workflow, but not everyone knows how to, I guess, create such relationships between certain items in an assembly to simulate the motion or the freedom in which some of the products move, right? You'll constrain it so it's like rigid.
Yeah.
And sometimes you don't want that in your assembly because your product can move up and down. Sometimes you have gas pistons that let things expand, so on and so forth. Brian's going to show a lot of that today, and that's why we came up with this topic. So if you have any questions, go ahead and type them into the GoToWebinar chat panel, and Brian and I will cover them during the session. I just realized this is backwards. So let me move this. And yeah, with that, I think we're going to go ahead and get started. Right. Anything else, Brian, before we go?
Nope.
Cool.
You covered it.
Go ahead and take over, man.
All right. Thank you, Nigel. So just adding to the why of why we're doing this, motions and assemblies, and these are more specific reasons. So just by constraints and having it become rigid alone adds value because now you have an assembly, you have some relationship between it. But a lot of the parts that we create, a lot of the assemblies we create move, and to be able to show that in your 3D model adds a lot of value to your CAD design. One of which you can show how the part is put together or the assembly. Another is its design intent, its design functionality. Like this arm here can move, can extend forward, it can collapse backwards, and things like that. You can show the different positions in which your design moves, as well as the manufacturing process. You can show how the part is meant to be put together or meant to be created from scratch. And motions can help to illustrate all these purposes, not only just in the 3D modeling world, but you can. And what I'm going to show you guys in a bit here is you can actually show that on a 2D drawing as well in what is called positional representation. So if you guys have any questions, like Nigel said, please leave that at the go-to in regard to that. So some goals today. First, we'll go over the fundamentals of joints and constraints, because these are the tools, the relationships you use to connect the components, the different components that you have in your assemblies. We'll be going over how to manage limits, the context solver, and drive constraints, as well as the positional representation to create our different representations of those 2D drawing views that I was discussing earlier, as well as using flexibility inside of. And that's when you have like a sub-assembly inside an assembly, and that's kind of like the solution to get the sub-assembly moving. So to start off, joints versus constraints. If you guys are at a beginner intermediate level, you should know this. But just to review, just in case you guys want a refresher or need a refresher on this, joints helps to fully define your degrees of freedom. It helps you to get straight to the point of what exactly you want your component to behave in. So for example, if you want to remove all degrees of freedom and you want your one component to be kind of super glued to another one, you can use something like a rigid joint and things like that. Constraints help to remove degrees of freedom as well, but this is like the older type of joint, I would say. And this was about 2014 and before is what we were all using before the joints came out. But with constraints, you can like put things on the same plane. It might take a few more steps using constraints to really create that relationship, the correct relationship between one component to another. But it also gets the job done as well. I would recommend joints though instead of it. If you can, because of just you can edit joints a little bit easier in some regards, but you can use constraints in conjunction with your joints.
And just to reiterate on that a little bit, or iterate more on that a little bit, Brian, the way I compare the two a lot too is, yeah, like you said, constraints are removing degrees of freedom, and then you define those degrees of freedom in joints. Usually, when you're creating a joint can be achieved by using multiple constraints. So if hopefully that makes sense, you can use like 2 constraints as opposed to 1 joint. So usually a joint is a lot lighter in terms of processing power to get the exact same result, right? And I don't know if Brian's going to go over that specifically, but if you have like large assemblies and stuff, and you absolutely need some sort of constraint or mate between 2 components that allow for some sort of movement, I would use a joint versus a constraint. And then if you want to make something like super rigid in a assembly that's super big, I wouldn't use either. It'd actually ground that component. It's probably going to be better.
Right, and grounding is another constraint, but in respect to the environment itself. All right. So now let's go ahead and dive into Inventor here. And here is the one of our examples, which is a vise that this handlebar would rotate, and then this vise, it would spin this shaft, which will push this movable jaw into the fixed jaw there. But right now it's missing some constraints and or joints, just relationships between the two. And if you see in that environment that they're moving around freely, and what we would want to do is actually, put them into the assembly here, so then they are behaving realistically. So first off, you want to see if which one you want to ground, like Nigel was mentioning, and this will put the part in respect to the environment that's in, so then that's not going to move. So you can choose one component, you can choose one sub-assembly to just ground. And in this case, we already have one. It's represented by this pin here. And just by right-clicking, you're able to ground or unground this component there. So that one's already grounded, and that's this piece right here. And if I try to move it with my mouse, that's not going to move, as opposed to another piece like that. So next, let's go ahead and get this movable jaw going along in respect to this fixed jaw there. So I will show you the constraint way and the joint way. A constraint might be 1 or 2 extra button clicks here, and I'll show you that joint can maybe resolve it in a quicker fashion. So right now, it can move left and right, up and down. And we actually don't want it to be able to move left and right. So I will go ahead and constrain this face right here to this face right there. That's only knowing that this distance from the width of this part is the same as this part, or then we'd have to take a different route. But since this is the case, we can go ahead and let me go down a little bit slower there. I'm going to hover over Constrain tool, and then there is the Mate type of constraint. And that's usually the generic constraint that we use. I'll go ahead and select that face there. And then it's going to move on to the second selection. I'll go ahead and select that face there. It flipped around in a weird fashion there. And I can see that I have different options to prevent it from doing that. So I'm going to select the flush option there, apply it, and now this is moving in the same, or oops, oh, it was moving in the same face there. One second here. What? Okay. Let me move a little bit slower there with my mouse. But essentially, this is now in the same plane as that. And I'm going to need one more constraint because it's still hovering over it. So I'm going to go ahead and constrain this face there to that face there. Once again, it's not behaving the way I want it to, so I'm going to flip it so then the planes are on or opposite ends there and hit apply. So now this flushes that and then the other one as well that I just created. So now this can move left and right. So that's the gist of a constraint. If I want to create the joints for this, we can do this in just one maneuver instead. So let me go ahead and Control Z to undo the constraint there, just to show that this is now has no more constraints or any relationships on it. I'll go ahead and go to Joint. And now we have a different window than the constraint one. And it's going to ask us for the first selection point. And when I hover over my removable jaw here, it's going to give me this red circle as well as the green dot. And the green dot's really important to joints because that's where the relationship's going to be created. So if I select that center point there and I hover over the second point, this green dot, they're going to eventually be touching. And then we can choose a relationship between the two. Once again, it's giving us a preview what it's going to look like. So I actually do want to be put on the opposite end of the fixed jaw there. Go ahead and animate that. It's going to be a rigid. It's shook, which means it's going to be a rigid joint, which is like that super glue that I was talking about earlier. Rather, I wanted to maybe have a slider reaction to that. So now it's behaving the way I wanted to. So let's go ahead and start adding the cylinder or the shaft here. I'll just go ahead and stick with the joints. Paying attention to the green dot from that point to that point there. It's going to rotate, or the center of that point there. I'm okay with that. And lastly, the handlebar here. Joint, the center of this handlebar, pay attention to the green dot, and then the center of that shaft. All right, so now we have an assembly that moves left and right, and the handlebar can rotate. Oh, so see there, it's kind of slipping. I can go back into my my joints here, and I actually want this to be a rigid joint, so then it doesn't slip when I'm moving my handlebar there. And there is a way to also make this rotate in respect to how many times it revolutes around the threads here and how this moves forward, but that's for another day. So now I want to go over how, when you move this into past the fixed jaw, how to prevent that from happening in this way as well. And we can use two different methods. There are the limits that you can create to stop it from going past, as well as setting contact boundaries or contacts for turning on contacts for this assembly. So first I'll do the contacts way. So if we go up here to Tools, Document Settings, Modeling, and Interactive Contacts for all components, you turn that on. You notice that now when I try to move this, it's not going to move. And this is a good way to test for if maybe your part was created incorrectly, and maybe in this case, the hole for the model is a little bit smaller than the actual shaft going in it, and that's probably why it's not moving. So you can help test for things like that. I wouldn't necessarily recommend contact sets for very large assemblies, because then a lot of contact is going to have to be generated, and it might bog down your computer. But for smaller assemblies like this, it's perfectly fine to run a contact set to test for things like that. So to fix that, just for now, I will go ahead and go into this part and maybe just change the hole size to make it larger. So now you can see that it's clearly large enough for the shaft, and it should be able to move. All right. And if I try to go to this fixed jaw, it's going to stop there because of it's hitting another body, as well as this way. I can't go any further there. But let's say we don't have the contact sets. The other way we can go about it is creating limits. And limits would be inside of that joint, that slider joint that we created. And instead of relying on a body for it to hit, we can rely on numbers from where it starts and where we want it to end, in a sense. So if we go over here to the limits in the joint window of the slider that we had, and if I choose the starting point to be 0, which is what it started with, so 0 millimeters, and I hit OK. Now this limit, now it's being controlled by limits, and it's stopping here not because of it's being in contact with the body, rather that it's being stopped by the number itself, by the limits. And if I want to create the endpoint of it there, I can turn on the endpoint, and I want it to stop at this wall here. So what I can do, I don't know the value at the top of my head, but what I can do is click on this arrow and hit measure, and I can measure from this face to that face, and it gave me that value in there. So now I can hit OK, and this is 0 over here, and I move over here, it should stop at 67 millimeters over there. So yeah, 2 different ways you can go about that. Limits is probably the one you want to go with because it doesn't rely on the visualizations of the software, rather it's just the numbers controlling it.
Yeah, also keep in mind too that every time you add criteria like that, like the limits and so on and so forth, the heavier this thing gets. So you're not going to want to do this kind of stuff if you can avoid it in large assemblies. And by large assembly, I mean like in the hundreds. Generally, it's going to be thousands of parts. But I would try to avoid doing that if possible. Also, if you do change the parameters for some of these things, the limits probably won't carry over. Say you change the distance between change the distance of this fixture, or the length of this fixture, that won't carry over in the limit. So you just keep in mind that if you do change the size of all of this, sometimes you're going to have to go and change that criteria for those limits too.
Yeah, you might want to involve parameters and variables inside your limits that could maybe reflect based off the change you make in the model, and that's something you can dive deeper into. But all right, so that's it for the general joints and constraints. Let's take a look at having sub-assemblies inside your assemblies now. So this is you can see here there's a lot of assemblies inside the broke arm assembly, and if I try to move it, it's not going to move. None of these pieces are moving. Only one of them is grounded, so that one I expect not to move, but these ones I thought would move. But in order to make a move, you want to turn on what is called flexibility. So if I highlight these assemblies here, right click and go down to flexible, now these parts will be able to move. And you can see that now when you make them flexible, you can see the parts that are not properly constrained. If you move it too drastically as well, it might behave in an odd fashion. So what I would recommend is first fixing the constraints and joints that might be missing after turning on flexible. But in addition, maybe only turning one thing to be flexible at a time. So for instance, I'm going to fix this this part right here and just go ahead and create maybe a constraint for this in this case. We don't need a joint necessarily. And now let's test it. So now it's behaving properly. And now let's go ahead and just turn off the flexibility and maybe just focus on one aspect of it. So for instance, the cylinder number 1, I can make that flexible. And when I move this part, only that one's moving. So it's not as crazy as all of them moving at the same time. All right. So now I know that this can move, to a certain extent, but then if I pull it too far, it's going to actually come out of the hydraulics. So how do I want to show whoever, the customer, the vendor, the manufacturing house, that like I only want to extend this far, and then and when it's collapsed or closed, I want the hydraulic to show this in this position. So let's go create some what is called positional representations that can help drive this model. So to do that, I'm going to go into my hydraulic cylinder and open that up. And now we have this hydraulic cylinder that can go in. Maybe that's a little too far there, and it can come out like that. So to create positional representations to show this, I already have two created here. I can go ahead and delete those. This is what it will look like. So I will go ahead and go to my position, right-click, and create new. And one more time for another one. And I can name them closed and open. And right now the closed one is active based off the check mark. And I want it to look something like this without going too far in. And to do that, let's go ahead and make this component transparent. So I wanted to stop at that point there. And luckily, we already have a constraint created here. So all I need to do is adjust this drive stroke constraint. And to do that with this new position check, I would right-click and do what is called overriding it. Now, overriding it allows me to change the position, and in doing so, I will enable a suppression for it, meaning whatever position it's in now, or whatever value I put in, is going to have to be in that position if I have this representation checked. So I want this to be at 0, so I don't have to change that value. Just got to check that box off. And then when I hit OK, it's going to move to that 0 position. And since it's the suppression is enabled, I cannot move this even if I drop my mouse. So it's forcing it at that 0 position.
And it's not necessarily, I think the wording there might get a little confusing too. It's not the suppression, like the suppression is enabled in terms of the box. What it's doing is it's suppressing the existing mate. So there is a constraint there that is 350 millimeters, I think is what it is, or something like that, that Brian suppressed and then it changed the value to 0. It's not necessarily we're suppressing that constraint. As you can see, this constraint is actually active, not suppressed. But we're suppressing the value of 350 and changing it to 0.
And then we want to do the same for the open, but not necessarily make it 0, make it a different distance. And it'll be just like that limits we created. So I'll go ahead and go to the open position. Right now we can move it around. I do want to have it go from this distance there, from the closed position state to that distance, to that face there. So let's go back to close, and I'm going to measure this. I'm going to use the measuring tool. I'm going to right-click and hold, hit select other, and now I can click through my assembly by hovering over these faces, and I want that face there. So it gave me one value right now. Do the same on the other side, select other to get that face over there. I have this distance now. I'll go ahead and copy that. And I'll go back to my open position, and now I have a value I can enter. So if I go here to my drive stroke and override that, I will suppress the 350. Maybe that was the value I did want to use, but this value is a little bit different. So I'll go ahead and put that one in, apply that, and now we have a open position that hits the end of the hydraulics inside there. So close and open. So now once you have something like that, you can save it, and when you go back to your assembly here, oh, there you go. It's a little lag there. Now when we go back to our assembly, we can take a look at the position representations inside here. So if I want to affect the hydraulic cylinder number 2, which is this one right there, I can go into the representations and maybe close it, and it affected the model there. And this doesn't necessarily have to be flexible. in order to adjust that. And if I want to open it, I can open it there. All right. And now let's show how we can put this in a drawing and how this can you can present this to whomever.
Yeah, and Mario asked a question earlier about like, and Brian, you can continue opening the drawing environment too. Mario asked a question earlier about like how far can we make these positional representations, or how deep can we go? I haven't tested it. I'm pretty sure you can go a couple levels deep in regards to positional representations. I don't know where that point stops, but I'm pretty sure you can go like at least a couple levels deep.
Yeah, you don't want to go too many levels deep, from what I've heard, but 1 or 2 is a good amount. Okay. So right now I'm putting in my views and I'm choosing the different positions that are available to me in the when I'm creating my drawings here. So this bottom one is the open, middle one is the master, and let's make this last one the closed view. And then you can go ahead and start dimensioning something like that. To show the different lengths of when it's closed and when it's open.
Yeah. What I actually do for these, I don't know if Brian's going to show it too, is to overlay them on top of each other.
Yeah,
so.
That's the next
yeah.
one I was going to show here. The overlay. So let's say we have the assembly now. We want to show the different views of that, the arm assembly. So I was going to go in here, change it to the assembly rather than the hydraulics. Put this in the center there more. And now we're going to use what is called an overlay to not just create another drawing per se, but overlay what this would look like in a different view. Right now, if I try to do an overlay of it, I don't have any positional representations to choose from. I can't choose these sub-assembly ones. But what I can do over here is actually create another representation. This one's kind of extended, so maybe I can call this maybe like a collapse view. And this might be useful for the manufacturing, the customer, and whatnot, because you can show that when this is closed, let's see here, close that. So when this is closed and this is now overriding because the original view was open or extended, when this is closed, you can show how close this machine can get to the manufacturing part of its functionality, and vice versa for the opening one. So now if I go to my overlay tool and select that view there, now I have positional representations I can choose from, or one other one. And once I hit OK, it shows like a dash view of that position, and you can dimension this as well to show that distance. And lastly, I did want to talk a little bit about drive constraints. So this would be where you can go into the model and affect the movement of it using an animation, in a sense. So for instance, if I go into my hydro cylinder here, I want to turn it on to adaptive in order for it to kind of animate or drive. But right now I'm going to have to maybe remove the override there, per se. Or maybe I can do it to a different one for this example. Let's see. Maybe make it not flexible there. Trying to find one to do a quick example here. Doing some Control Z's here. Okay, maybe this will be for another day, but essentially, oh, there we go. I turn off the flexibility. Now I can make this adaptive. And once it's adaptive, I have the option to go into one of my relationships and drive it. So if I drive that there, oh, it's not. Let me show it on my hydro cylinder instead. So if I go to perhaps a master position there, and I go into drive this model, I can animate that without having to actually move it. And I can control the distance in which I do that. So I can animate that to go all the way out like that and move it all the way back in like that without moving it with my mouse. And this is something you can record and save as an MP4 and things like that. All right. So to recap, we showed you how to use joints in conjunction with constraints to define degrees of freedom. It's good to use positional representations to show in drawings how you can show like a collapse or extended view, closed or open views of your design functionality. And sub-assemblies should be flexible in order to move them inside of the of another assembly, unless you use the positional representations, and they will move like that. So.
Okay. Yeah, thank you all for being part of our community. We hope to see you here next week and all of the following weeks, Thursday at 10 a.m. Pacific, for those of you who aren't in the time zone. So thanks, everybody, and we'll see you next week.
Thanks, guys.